Hey there, welcome to a video discussing chapter 10, which is on the introduction to probability. So this video should be pretty short, and then after the video, you'll be asked to read the textbook on chapter 10 and answer some problem sets or answer some questions on a problem set for chapter 10. And then of course, if you look at homework, the probability homework at Schoology, there'll be a Google form for you to fill out so you can put in your answers and answer other questions about probability. And I'll show expectation of Schoology just a little bit. But the first expectation for today is to watch or take notes. You're obviously watching this video if you have it on, but it takes some notes and just pay close attention to what I'm about to discuss. So idea of probability. So probability is a science of chance behavior. I find probability actually to be one of the most fascinating fields of mathematics because it really kind of helps us understand or to be able to predict certain behaviors. So at its core, probability is really just this. The number of favorable outcomes divided by the number of total possible outcomes. And if you are listening very closely, you might hear my daughter in the background. I think she needs help with something. So I'm going to pause this video very briefly. Okay, I'm back. Sorry for that slight delay. My daughter wanted me to put on her rain boots and rain jacket, even though it's nice and sunny outside. So go figure. Anyway, so at its core, probability is a number of favorable outcomes by the number of total possible outcomes. Say, for example, we have 600 students, and we want the probability of picking a freshman out of those 600 students. If we have 100 freshmen and 600 total students, then the probability of picking a freshman would be 100 out of 600, or 1/6. So those just cancel, you get 1/6. So that's all probability really is. It's just the way of computing the chance of something happening. That's what we call the science of chance behavior. And again, I find it fascinating because it can offer some sort of predictability to a rather unpredictable kind of situation. So you can see the second bullet point, chance behavior is unpredictable in the short run, but has a regular predictable pattern in the long run. So for example, if I were to try to, if I had like 600 names of students and 100 of those names were freshmen, say I took pieces of paper and put them all in a hat, and I, put all the names in the hat, and of course I labeled each piece of paper whether it's freshman, sophomore, junior, senior. If I were to do this, like say 12 times, 2 out of those 12 times I should pick a freshman, but could be maybe I pick 4 freshmen out of 12 times, or 6 freshmen out of 12, or maybe no freshmen out of 12 times. But if I do this for a very long, if I do this repeatedly for a very long time, let's say I do this like 1,200 times, then I should expect about 200 of those 1,200 to be freshmen. So usually after a while, we should expect this outcome. So another way of thinking about it, let's say you're looking at the game of a roulette wheel. So say you have the game of roulette. And there's 36 numbers, and there's actually a 0 and a double 0, believe it or not. So there's actually 38 numbers in roulette. So what's the probability that the ball is going to land on a 2? Well, obviously just be 1 out of 38, because there's only 1 2 on the wheel, and there's 38 possibilities. So this means if I play roulette 38 times, at least once, should I see the number 2? Probably. The 2 could land, multiple times in 38 spins. Maybe it lands 5 times or 6 times. Also may not land at all. In fact, you might play roulette 100 times and the 2 never lands. But if I were to play roulette 38,000 times, or I play 38,000 times, I would expect a 2 to show up 1,000 times or close to it. So if you do it for a long time, ultimately the probability that we would theoretically get should actually happen, or should come close to happening. So that's why we can use probability to gain useful results from random samples and randomized comparative experiments. So we definitely want randomization in order to make sure that our experiments are accurate. And random means individual outcomes are uncertain, but there's a regular distribution of outcomes in a large number. I emphasize the word large number of repetitions. Relative frequency, the proportion of occurrence of an outcome. So just how often we expect that to happen. Can be determined by observing a long series of independent trials. So you want some, each trial is independent. So that means that, like if I spin a roulette wheel, the second spin doesn't remember what the first spin did. There's no memory of it. And so you just, or like if you're drawing cards out of a deck, you draw a card of a deck and then you put all the cards back and you shuffle again. So you want to make sure every trial is independent from the other trials. And again, you want to get a large sample, like, usually like thousands of trials would be good. And basically, we kind of settle down to one value over the long run. So again, for just for a long time, we find set on one value. That's the probability of the outcome. So that's what's meant by relative frequency. It's really just the same thing as probability. The proportion, because probability is a fraction, right? Now we have something called our sample space, meaning all the possibilities. So in the roulette wheel, remember there's a 0, a double 0, number 1, 2, all the way till number 36. So that's our sample space. And usually we write like in a set notation like that. An event is whatever outcome we are hoping to get. So the event that we roll a 2, or that we spin the ball and lands on a 2, that's an event. And the probability model is just basically the best way to think about it, it's just really a mathematical description of what we expect to happen. I mean, I guess you could, I'm just struggling to answer this question because you can write the model in so many ways. I suppose like you could make a table. You can say, okay, what's the probability of getting a 0, a double 0, a 1, a 2? Obviously, to get any of these is 1 out of 38. But if you're playing a deck of cards, there are a lot of different scenarios that happen with a deck of cards. For example, say you draw a king from a standard deck of cards. So what is a sample space? Well, the sample space, obviously, there's an ace, a king, a queen, a jack, and then the number 2, 3, all until number 10. So there are actually going to be 13 types of cards. We won't talk about jokers. So say the jokers are out. So the probability of getting a king is 1 out of 13. Or you could say there are 4 kings and there are 52 cards, because there are 52 cards in a standard deck. You have 4 of each type. So you can also say 4 out of 52, which is still the same thing. It still reduces the 1/13. But the sample space I wanted to kind of keep simple. I didn't want to write all the 52 cards, like, okay, you got the ace of hearts, the ace of diamonds, the ace of clubs, ace of spades. That just takes too long. The probability of event happening is always between 0 and 1, inclusive. So it's never going to be negative. You're not going to have a negative probability, because remember, probability at its core is a number of favorable outcomes. That's something you can count, right? It's a counting number. It's a whole number. You're not going to have a negative number of kings in a standard deck of cards, right? It's the number of favorable outcomes divided by the number of total possible outcomes. And obviously, the number of favorable outcomes is not going to be more than a total. If you have 52 cards, you're not going to have 53 kings and 52 cards, right? That's crazy. That's impossible. So it's never going to be more than 1. But if the probability is 1, that means that it happens 100% of the time. If probability is 0, it means it never happens. We're also going to talk about combining probabilities. We'll do that sometime next week. But if events A and B are disjoint, meaning that they won't have anything in common, like for example, what's the probability of drawing a king or a jack? There are no cards that are both king and jack. But if you ask what's the probability of drawing a king or a heart, there is obviously a king of hearts. That would be a different scenario we have to deal with. But as long as the two events are disjoint, meaning they don't have any overlap, So disjoint means no overlap. Then you can just add the two probabilities together. So another thing is like, what's the probability of rolling a 2 or we play roulette, you spin and get a 2, and then getting a 5. Again, those are two. You can't spin a roulette wheel and get a 2 and a 5 at the same time, right? Those are disjoint events. Just keep that in mind that you don't want overlap for disjoint events. Then you can just, and if that's the case, you can just add the two probabilities. For any event A, the probability A does not occur is one that's probability does occur. So say, for example, I want the probability of no king, then it's 1 minus 1/13, which is 12/13. Now that is kind of easy to compute without doing this formula, because if you think about it, there are 12 cards are not kings, and there are 13 types of cards. But you can also use the formula too if it's hard to imagine the probability of something not happening. If you can't really count it very easily, then you do 1 minus probability of it happening. And usually we call this the complement. The probability of something not happening, we call it the complement. Discrete probabilities, again, these are countable outcomes, right? Countable, I emphasize that word, these are countable. Infinite, meaning that it's not infinite. That means that there's only a certain number that we have. And so what we do is you assign probably each individual outcome where the probabilities are numbers between 0 and 1, and all of them will always add up to 1. So for example, when you're spinning the roulette wheel, you have a 0, a double 0, the number 1, 2, and so forth. That's 1 out of 38 for getting a 0, 1 out of 38 getting double 0. And if you add up all those individual probabilities, all of them will always add up to 1, because that's going to be 100% of the outcomes. So let's talk about rolling 2 standard dice. That's also very popular. The game of craps. That's actually a fun game. And I think probably by now you probably recognize the fact that I probably have an affinity for casino and gambling games. That's why I think probably so fascinating, because it helps you understand how those games work. Just so the house always wins, but nonetheless, it's always fun to play. So that's one reason why I find this such a fascinating topic. But if you're rolling 2 dice, remember dice has 6 faces. It's a small cube, and obviously there's 6 numbers on there. Like there's like a dot and like 2 dots and so forth. And so if you want to roll an 11, we roll 2 dice. There's 2 ways that could happen. You could roll 5 and a 6, or a 6 and a 5. So like one die could have 5, one die could have 6, or the other could have 6, and the other could have 5. How many possibilities are there? Well, there's 6 possibilities on one die and 6 on another. So there's actually 36 outcomes total. So the answer is 2 out of 36, or 1/18. And if you were to actually look at all the possibilities, probability of rolling 2 dice. Here we go. So you can see here, the probability of getting 11 is 2 out of 36. And all these will add to 1, because these are all the possibilities. Like if you roll 2 die, the lowest number gets a 2, the highest number gets a 12. And that's what happens. If we get a chance, maybe we'll play the game of craps. And that's kind of a fascinating game. There's some certain rules that you guys might be aware of that I could share with you guys, but usually rolling a 7 is a good thing, and that's a 1/6 chance, but sometimes 7 could be a bad thing too. So we'll definitely do some simulations, and there's also betting strategies and stuff like that. So again, that's why I find stuff fascinating. It's deals with money and gambling. So, continuous probabilities. Sometimes we may not be able to assign probability to each individual outcome because there are infinite number of outcomes. So that can happen. I'm trying to think of scenarios where that could happen, but can't think of any off the top of my head. Oh, actually, I suppose this, when we do the like when we do z-score stuff, like the probability that like say the mean height of somebody's like say the mean height of freshman is like 50 inches and standard deviation is like 2. what's the probability that we pick somebody that's greater than, taller than 52 inches? That would actually be a continuous probability. We've actually done stuff like that. And so we'll kind of come back to normal distribution in a little while. But there are, we do look at curves, like a normal curve. So remember we had a normal curve, and like, let's say like you're looking at heights of students, say the mean's 50 and say the standard deviation is like 2. So what's the probability they pick someone's taller than that? That's actually a continuous probability, because there are a lot of different situations. I mean, you could have like the probability of something happening is like, 20.5% or 28.64%. So it's not a counting situation. So for example, find the probability of getting a random number that's less than or equal to 0.5. Obviously, there's infinite numbers less than or equal to 0.5, like 0.4, 0.001, or getting a number greater than 0.8 between and the number between 0 and 1 will be chosen. Again, those are infinite possibilities. So that's what's meant by that. And we have talked about normal curves, so we'll revisit that. Won't get into that those details just yet. Random variable. You'll see it in the textbook when you read it. This variable whose value is the numerical outcome of a random phenomenon. Well, actually, I'll take a look at the textbook so you kind of see how that looks and some of the problem sets. But usually we tend to use symbols like alphabetical symbols to represent a random variable. And there will be a mean and a standard deviation associated with that. We do a probability distribution, and it can be done for discrete or continuous situations. For example, you could say, what's the probability that, trying to think here, say you go to like a pizza place, and like, what's the probability that some pizzas will have pepperoni on it? Like, so they say the place sells 100 pizzas. What's the probability that 100 of those pizzas will have pepperoni on it? That's something that'd be finite. Continuous again with something that will follow like a normal distribution. Where again, these are anything you can count. And then personal probability, that's more like when people kind of like guess, like in conversation, like what you think is going to happen. Like, for example, I think the Rams have a 70% chance of winning. I mean, how did I come up with that number? I just came up with that number. So it's not anything that really is scientific necessarily. But you could, for example, like you could say like, hey, these teams have played each other 5 times in the last 2 years, and this team won 4 of those 5 times. So maybe you say, yeah, they have 80% chance of winning. Sometimes you could say that, I suppose. But anything can happen in any game. For example, like in baseball, teams play each other quite a lot. Like, for example, the Giants play the Dodgers usually about 20 times a year. So the Giants beat the Dodgers 16 out of 20 times. So if they see each other in the playoffs, the Giants have an 8% chance of winning. Well, no, just things could change depending on what time of year they're playing and who's hurt, or if the team picks up a new player. But it's just something that we sometimes have personal belief or judgment about. It says you use this time probably when it's not feasible to observe outcomes from a long series of trials. Yeah, like for example, the Bengals are playing the Rams. I don't think they've seen each other. I can't remember the last time those 2 teams played each other. So it don't really have a bunch of like games to look at. And even if you did look at games from like 10 years ago, they had different players then, different coaches, different styles of the way they play football. So yeah, I sometimes we'll need to rely on other types of modeling or other types of criteria to make that kind of judgment call. So anyway, that covers this video on probability. Hopefully you got something out of it. Again, there are some textbook problems here. If you look at the textbook near the end, it does summarize everything about probability. Random variables, it says, it's going to show you really quickly. So this is an example of like using random variables. So apparently they're looking at the number of grade point averages. For example, an A is worth 4 points, an A minus is worth 3.7, a B plus worth 3.3. And they're looking at the probability of each of those happening. So these are what we call discrete, because these are only, it's not continuous. It's not like you can get a grade between an A minus and an A. I mean, your GPA would probably be continuous, I'd say, because GPA could be anywhere from 0 to 4, any number. But your grade in a class would be discrete. We'll have this discussion on Friday for sure, but GPA would be continuous. And so we call this a random variable because, yeah, I mean, maybe we randomly assign grades, and then we look at the probability of each of those situations. And all of these have to add up to 1, just so you know. If you look at the entire class and how you distribute the grades. So for example, if you want this, that means the chance of getting a B or better. And when you look at that, you see that, okay, they're probably getting a B or better. If I add up, that's 0.24, 0.7, so about 0.41. So you have a 41% chance of getting a B or better. This actually is very useful knowledge if you're gonna register for a class in college and you know this information going in, like, they show the grades of how the grades, and maybe you need like to, maybe you need to get a B to get your GPA over a certain number so that you can maybe qualify for a scholarship or get a job at a company or internship, whatever, and you figure, geez, only 4% of people get B's. I may not want to take that class. Let me pick a different class that has a better chance of getting a B or better. I mean, not sure if this knowledge would be made available for classes, because sometimes hard professors don't want you to know that, because then no one will enroll in their class. But you can see how this could be useful, right? This could be very useful knowledge. And so you'll have some problem sets to work on. They'll also deal with random variables. Like, for example, like this one here, this is number 31 and 32. The probability makes at least 1 free throw. So that means that that'd be the probability of X greater than or equal to 1. We would want to say A for that one. The probability makes, and then the actual probability would be 0.91, because you add those two numbers together. So that's like how random variables would work. Pretty straightforward. So that's what we have going on there. Anyway, I think that pretty much covers it. So you guys will just flip through the textbook stuff, then do the problem sets. That you can only do 1 through 43 odd. By the way, let me show you Schoology really fast. So here's a probability homework. 1 through 43 odd. And there's a Google form that I want you to fill out. Make sure that link works. Tap in your name, put in your answers here. You should be able to go through these problems pretty quickly, even though it's 22 questions. And then they also kind of like define what is probability in your own words, some of the stuff about probability. And please get this done. This is due this Friday, 8:30 a.m. So you should be able to get it done in class today. If not, then you have to do it tonight or tomorrow. If you don't have it turned in, I have to give you a 0 on this assignment. And I'm gonna have to have a conversation with some of you guys about our last unit test, or the makeup test. I know some of you guys did a makeup test and it didn't go well for about half of you guys. There's not gonna be a third retake, unfortunately. I can't write a third copy of a test. That's just not gonna happen. But I do need to hold you guys accountable. So we're gonna have a conversation on Friday about that, because yeah, I mean, I want you guys to do well in this class. And if you're not, like confidence interval, some of you guys didn't do very well with that unit. I've gathered you probably didn't do the work, or probably didn't really take the work seriously. And you guys are seniors, I shouldn't be holding your hand, but maybe we need a little hand holding, a little spoon feeding. I don't know. We'll talk on Friday. So now you know what's coming. Don't worry, I'm not gonna be kind about it and kill you with kindness as I always do. But we do have to have a heart-to-heart talk about work ethic in this class, because I want to make sure you guys are working hard and getting something out of it. It's not just kind of just not caring. I want you guys to be engaged. So yeah, we're gonna have that conversation. So anyway, I will end the video now. and have a great day. And I will see you guys on campus on Friday. Goodbye.